First, we'll draw our equilateral triangle ABC, and then our 60-degree angle. So this is DEF, and we're asked to find the side length AB, so we'll call it S. And we'll fill in these other lengths. AF is 5, so FB is S minus 5. CD is 2, this is S minus 2. We'll call AE X, so this is S minus X. Then we'll use the formula for the area of a triangle. That's 1/2 AB sine C. So for this top triangle, the area of triangle AEF, we have a 60-degree angle up here, so this is sine of 60 degrees. And we'll substitute. This is root 3 over 4 times 5x. And we'll repeat this for triangle BDF. I'll pull out the root 3 over 4, and we have s minus 2 times s minus 5. And the third triangle on the right, CDE. And the two side lengths are 2 and s minus x. And we note that the area of the equilateral triangle ABC is root 3 over 4 times s squared. Also, this is 60 degrees. To find the area of triangle DEF, in terms of the areas of the other triangles, we'll start with triangle ABC and subtract the three other triangles. We're given the area of that center triangle, and I'll go ahead and factor out root 3 over 4 from these other areas. So inside the parentheses, we have s squared, and then we'll subtract 5x, this product, and 2 times s minus x. Multiplying both sides by 4 over root 3 gives us 56 on the left-hand side, and we'll FOIL these out and combine like terms. Here's 5s and minus 3x and minus 10. So 5s minus 3x equals 66. Since we have some congruent angles in these triangles, let's look for similarity. From the angle sum of triangle AEF, we have these two lower angles, angle AEF and AFE. They're going to sum to 120 degrees. These three angles around this point E are supplementary with a 60-degree angle in the middle. So we have angle CED and AEF also sum to 120 degrees. We have angle AEF in both of these equations. So we have that angle CED is the same as AFE. And I'll mark them here in pink and sketch them down here with the corresponding sides oriented the same way. So this is C and E and D. CD is 2 and CE is S minus X. The sides that correspond to CD and CE are AE and AF. So we'll substitute, multiply by the denominators, and we'll compare it to the other equation that we found here. So let's take this and solve for s minus x by dividing by x. To plug this into our first equation, let's factor out a 5, and we'll add 2x over here to balance. And now we can substitute, and we have just one variable now. We'll multiply by x to get our quadratic, and divide by 2. This won't factor, so we'll use the quadratic equation. First, let's find the discriminant. This is 989. So here are our solutions for x. And we'll separate out our terms in the numerator because they want the solution written as p plus or minus q times the square root of r, where r doesn't have any perfect squares that divide it. I want to make sure that there are no perfect squares that divide 989. First, we ensure that 989 itself is not a perfect square. These are our consecutive perfect squares, so 989 is not one. So if n squared divides 989, then there is the square of some prime multiplied by a constant that's equal to 989. Dividing by k and taking the square root, we can use this to find the upper bound of the primes that we need to check that divide 989. To maximize this prime, we minimize k, where it's equal to 2. However, we can tell by inspection that 989 is not a multiple of 2, so we can eliminate that. We can also tell from the digit sum, since it's not a multiple of 3, we can also eliminate 3. And since the units digit is not a 5 or a 0, it's also not a multiple of 5. So let's just start with k equals 7. We'll find divisibility by primes up to the square root of 989 over 7. This is about 141, and the greatest prime that's less than the square root is 11, so we'll check the primes 7 and 11. But in fact, we already know that it's not divisible by 7, and then we can use the alternating sum formula to check for divisibility by 11. So in fact, there are no perfect squares that divide 989. So the answer to this problem, R, is 989. If you'd like me to solve any other math contest problems, please leave them in the comments.